In this video, we're going to be solving systems of equations that are application problems. And this one in particular, here on the right, is a mixture problem. It says, a lab technician wants to produce 20 milliliters of solution with 45% acid. To obtain this, a 50% acid solution is combined with a 30% acid solution. How many milliliters of the 50% solution and how many milliliters of the 30% solution should be used to make the desired 20 milliliters? Alright, again, as I mentioned in the last video, we really want to define our variables before we begin. So the question is, what don't we know? We don't know how many milliliters, so the number of milliliters of the 50% solution we should be mixing with how many milliliters of the 30% solution. Once we have defined our variables, we can start writing our equations. We know that we have a total of 20 milliliters of solution. So the number of milliliters here plus the number of milliliters there should add up to the 20 milliliters. And that gives us our first equation. X plus y equals 20. Our second equation involves the percents of acid in each solution. So to look at this, we're basically going to take this first equation here and then throw in the percents of each type of acid. Remember that all these percents we should change to decimals. And when we change a percent to a decimal, it's dividing by 1/3. So this was the 50% solution, so I would take the percentage as a decimal. 50 divided by 100 is 0.50, times how much of that solution I have, plus y was the 30% solution, so 3/10, or 0.3, times how much I have. So the percent of the solution times how much of the solution I have should equal, so if I'm adding these two solutions together, it should equal the total solution. So we want to end up with a 45% solution. So as a decimal, 0.45 times how much, which in this case we know is 20. Percent of the solution times the amount, plus the percent of the solution times the amount, and percent of the final solution times the final amount that I have. And those are my two equations. To solve this, again, I'm solving a system of linear equations in two variables. I can either use substitution or use elimination. I'm going to go ahead and use elimination so I don't have to deal with these decimals too much, more than I need to. And I'm going to go ahead and simplify this equation a little bit. That same equation, and then I can just multiply the 0.45 times the 20. If I multiply those together, I get 9. Alright, if I want to use the substitution method, I need to start by getting one of the variables alone. So again, you can choose to get any variable alone that you want. We're going to try to pick one that's the easiest. Again, in this equation, I can easily get x or y alone. I'm just going to go ahead and stick with getting x alone by subtracting y from both sides. And once I do that, I end up with this new equation here. X will equal 20 minus y. I'm going to take that expression and plug it in for x, because that's what x equals. X equals 20 minus y. I replace x with 20 minus y using the other equation. So in the second equation, replacing x with 20 minus y. And everything else stays the same. And again, that 9 came from just multiplying these two values together. Once I have one equation with one variable, I can solve it for that variable. I'm going to start by distributing. 0.5 times 20, well, that's the same thing, it's just half of 20, which is 10, and 0.5 times negative y is negative 0.5y. Everything else is staying the same. Move on to combining my like terms. Negative 0.5 plus 0.3y gives me negative 0.2y, 2/10 y. The goal is to get y alone, so I need to get rid of this 10, get rid of the constants next. I do the opposite, so I subtract from both sides. I'm left with negative 0.2y. Don't lose this negative, it went with the y, equals 9 minus 10 is negative 1. Again, I want to get y alone, so I divide by negative 2/10 on both sides. And I end up with y equals negative 1 divided by negative 0.2 is positive 5, and that's milliliters of the, I'll go back up here, y was the 30% solution. So 5 milliliters of 30% acid solution. Now that's only half of our answer. I also want to know how much of the 50% solution. Again, we go back up here and we have this nice equation already that tells us what x will equal. X will equal the 20 total milliliters that we need minus the 5 that we're using of the 30 leaves us with 15 milliliters that we'll need of the 50% solution. In general, these mixture problems, I start with the total amount of what I need, right? I need 20 milliliters. 20 milliliters. So I know that however much of this plus however much of that has to be the 20. And then I move on to the percents, right? These solutions have a percent of acidity. So I take the percent of acidity times the amount. Do the same with the other solution. When I add those together, I need to get where the totals are. I want to end up with a 45% acid, and that's times the amount of acid I have. Right? So percent times the amount plus the percent times the amount will equal the total percent I need times the total amount that I need. Alright, I hope that helps.